Hello, good morning. Welcome to today's class. If you're online, say hi. Let me set a poll. Good morning. Welcome to today's class. Who are those online? Are you ready for today's class? Veronica, hi. How are you today? You're welcome. Please, if you're online, say hi. Let's know how many we have before we proceed. Good morning. Fubara, you're welcome. How are you today? Fubara, this is the first time I'm seeing you here. You're welcome. All right. Good morning, students. Good morning, class. Good morning, everyone. Today, I want to continue from where we stopped on machines. Yesterday, we were able to look at few types of machines. We looked at the lever, the pulley, and the inclined plane. So today, we want to look at the various types of machines and how we can relate them to their formulas and how we can solve problems involving them. Okay? And we must not forget that the essence of this type of machines is for us to pick their velocity ratios, that we can substitute them into our main formula, then we solve our problem. All right, so let's look into the next type of machine. Okay. Nakuzi Onyeka, thank you so much for coming. All right, so let's explain this type of machine. This is a screw jack. This machine can be used to lift a heavy load such as a car. For example, if you have a flat tire, we are going to use this machine, which is a screw jack, to lift this car up so that you can easily change your tire without stress. Okay, so this is the what? The screw jack that we normally use to do what? To raise a car. All right, there are some that are modernized that you can just do this, the wheel like this is going to raise the body of the object up without much stress. Now the velocity ratio of this screw jack is 2 pi r over what? P, where r is radius and p is pitch. Now pitch is the difference between this successive thread here in between the jack. Is that okay? So that is our what? Our p, which is what? Pitch. Is that clear? Now you must note that velocity ratio has no SI units. So if this R is meter, that means the pitch will also be in what? In meter. But if one is in centimeter, the other should be in the same unit, which is centimeter. So that at the end of the day, it will have no SI unit because it's a constant. Is that clear? Or rather, it's a dimensionless quantity. All right. Veronica, you're welcome. All right, put it down fast. Let's proceed. Are we done? All right. Veronica done, Osakwe done, Fubara done. I should draw line on both sides. Okay. All right, let's proceed. Now let's look at question. All right, put down this question. Let's solve together. All right, Osakwe, can you see it clearly now? I've adjusted it. Okay, noted. All right, please copy what you have on the board. Let's solve together. All right, are we done? At Osakwe Veronica. Fubara, are we done? Okay, so let's proceed. All right, the question says the pitch of a screw jack is 0.5 centimeter. The arm is 50 centimeter long and its mechanical advantage is 250. What is its efficiency? And we should leave our answer in terms of pi. So if you heard what if your answer in terms of pi, it means you're going to leave pi as pi. You're not going to change the value as pi of pi. Remember that the value of pi is 3.142, right? Or 22/7. So in this question, I'm going to leave pi as pi without changing it. So let's solve. The pitch of a screw jack is 0.5 centimeter. So my pitch is 0.5 centimeter. Okay. And the arm is 50 centimeter long. That is the radius. R becomes 50 centimeter. The mechanical advantage, MA, is equal to 250. What are we looking for? Efficiency. Now, before we be able to solve it, you must get the velocity ratio. And the velocity ratio of a screw jack, VR, is equals to 2 pi r over pitch. Is that clear? Now, how do we solve it? It said VR is equals to 2 pi. What's my r? My r is 50. There is one thing you must note. The pitch is in centimeter and r is in centimeter. So the unit is this correct. So you don't need to do any conversion. So I'm going to say 2 pi r. My r is multiplied by what? 50. My pitch is 0. What? 5. Is that clear? So you're going to multiply and divide by this. VR is equals to 2 times 50 is going to give me 100. So that is 100 what? Pi. Because we're leaving our answer in terms of pi divided by 0. What? 5. Now by the time you divide it, you're going to have it to be what? 200 pi. Is that okay? You may be asking how we got this 200. 0.5 is something as 1 over 2, right? So by the time you divide, you're going to get 200. So the next thing to do is to find our efficiency. Our efficiency is equals to what? MA over VR, then multiply by 100%. Okay? Now, what's my MA? My MA is my mechanical advantage, which is given as 250, and my VR is 200 pi multiplied by 100%. Is that okay? All right. So what can go? 0 can cancel itself to give us 1, right? Now, 5 can go to give me what? 5. 5 can go to give me what? 4. Of which by the time you divide this, you are going to have 0.8. Now, this is efficiency is equals to 0.8 over pi multiplied by what? 100%. Is that clear? You can see use your calculator to confirm what I did. Now, 5 divided by 4. Okay, sorry. The answer is not 0.8, is 1.25 because this is up to 1.25 over pi, right? Multiplied by 100. Now, by the time I multiply 1.25 multiplied by 100, I'm going to have 125 over pi percent. Do you understand? So let me repeat myself. Let me do a recap. The pitch of a screw jack is 0.5 centimeters. The arm is 50 centimeters long. And its mechanical advantage is 250. What is this efficiency? We have to leave the answer in terms of what? Pi. Now, how do we solve this problem? We are going to solve it by stating our parameters. Our pitch is 0.5 centimeter. Our radius is 50 centimeters. And we're given our MA, which is mechanical advantage, to be 250, right? Now we are looking for efficiency. Before we can solve for efficiency, we must first solve for our velocity ratio, which the formula is 2 pi r over what? Pitch. Is that clear? All right. So we substitute into what we have. VR is equals to 2 pi multiplied by 50 divided by 0.5. Is that clear? All right. So by the time we divide it, we are going to have what? 200 pi because we're leaving our answer in terms of pi. Now, efficiency is equals to MA over VR multiplied by 100%. Okay, so my MA is 250, my VR is 200 pi. Now I have to divide to get 1.25 over pi multiplied by what? 100. Now efficiency is equals to 125 over pi what? Percent. Is that clear? Right. Is that clear? Are we done writing? Are we done writing? Do we understand? All right, so let's move to the next example. All right, copy what we have on the board. Let's solve together. All right, so we can proceed. The question says a screw jack whose pitch is 4.4 millimeters, millimeter is together, millimeter, okay, is used to raise a body of mass 8,000 kilograms through a height of 20 centimeters. The length of the tummy bar of the jack is 70 centimeters. If the efficiency of the jack is 80%, calculate I, the velocity ratio of the jack, the mechanical advantage of the jack, the effort required in raising the body, and the IV, the work done by the effort in raising the body. Now, these are the parameters given in this question. We must note that our pitch is 4.4 millimeters. Now, this is our mass. Now, the height, that is distance moved by this object, is what? 20 centimeters, okay? The length of the tummy bar becomes our radius, that is 70 centimeters. All right, and the efficiency is what? 80%. Now we are going to clean it off. As I gave you the question, so we'll start solving it one after the other. All right, so stay tuned. right. Now from the question, our pitch, I hope you are following. Our pitch P is given as 4.4 millimeters from the question, and we have the mass of the object, that is the mass of the load, is given as 8,000 kilogram. Now we have the through a height of 20 centimeter. Now that is distance moved by this object is equals to 20 centimeter. Then what again? The length of the tummy bar, that is the radius, is given as 70 centimeter, and the efficiency is given as what? 80%. Now we are giving G, acceleration due to gravity, to be 10 meters per second square, and we are giving pi to be what? 22/7. Okay, now we can proceed with the solving. I hope you can hear me. We can proceed with the solving. The first thing that is going to happen, or the first thing you are going to do, is to do unnecessary conversions. Now look at, all standard units must be in meters instead of millimeter, right? Now our pitch is given as 4.4 millimeters. We're going to convert it to meter. Then our distance moved by the load is given in centimeter. Our radius is given in centimeter. So let's do our necessary conversion first before we solve. Now my pitch is given as 4.4 millimeters, right? I'm going to convert it to meters by dividing by 1000. I'll divide by 1000. Okay? So I'll say 4.4 divided by 1000. With the help of your calculator, I'll have 4.4 times 10 raised to power what? -3. So it's now in meters. Okay? So distance moved by load is given as 20 centimeter, right? So I divide by what? 100. Because for you to convert centimeter to meter, you divide by 100. So I'm going to have 0.2 meters, right? Now my radius R is given as 70 centimeter. Still we divide by 100. Okay? So we have 0.7 meters. Is that okay? Now the first thing we are going to do in this question is for us to calculate the velocity ratio of the screw jack. And the formula for the velocity ratio of a screw jack is equals to 2 pi r over what? Over pitch. So let's substitute into what we have. This is 2 pi. We can remove the value of pi by saying that pi is what? Okay, let me break it down. VR is equals to 2 times, what's my pi? 22/7, which is the same thing as what? 3.142 is equals to 3.142 multiplied by, what's my R? My R is 0.7, then divided by what? The pitch is what? 4.4 times 10 raised to the power of -3. Is that clear? Okay, so we'll bring it down. Let's multiply to see what we have. We have 2 times 3.142, then times 0.7. I'm going to have 4.3988, okay, divided by 4.4 times 10 raised to the power -3. Is that okay? All right, so let's divide. 4.3988 divided by what? 4.4 exponent -3. Okay, so I will have 999.73. Now we can approximately round it up to 100 because this 7 is up to 5. Okay, let's see. You can round it up to be a whole number. We round it up. This 7 is up to 5. Add it here, make it to the 1000. So I have the velocity ratio to be 1000. I hope that is clear. Is that clear? Okay. Fubara, can you see it clearly now? Is it better now? Fubara, is it clearly now? Can you see it well? All right, so let's proceed. Now, the next thing we are expected to solve, this one is my first question, which is velocity ratio. Let me go to the next one, which is what? Mechanical advantage. In this question, I'm going to be using efficiency formula. Efficiency is equals to MA over VR multiplied by 100%. All right, so what is my efficiency? The value is 80 over 1 is equals to, what's my mechanical advantage? That is what I'm looking for. All right, my velocity ratio is given as 1000, then multiply by 100 over 1. Is that clear? All right, so what you are going to do is to say 80 over 1 is equals to MA multiplied by 100 is going to give me 100 MA, okay, divided by what? 1000. So what do? I do cross multiply. 100 MA is equals to 80 times 1000 is going to give me 80,000 divided by what? 100. All right. So I have MA is equals to 0 cancel 0, 0 cancel 0. So my MA is equals to 800. Do you understand? All right. Fubara, is it clearer now? I hope you understand. Please, if you are just joining us, give it a thumbs up and not forget to subscribe to this channel. All right, are we done? Do we understand? Let's proceed to the next one. All right, so let's clear so we can solve the next one. All right, so the third part of the question is for us to solve the effort. the effort required to raise the body. That's the third part. And how do we solve for the effort? You know that mechanical advantage is equals to load over effort. If mechanical advantage is equals to load over effort, so what do? We don't have the load, but we have what? The mass of the load. Now I tell you that load is a force and effort is a force. Now, and force is equals to weight, and weight is equals to mass times gravity. So this is equals to mg, right? Now we are giving them 80,000, okay? Multiplied by g is 10. I have g as 10. So my load is equals to what? 800,000 Newton. Is that so for the effort? Remember that my MA, I've gotten it to be what? 800 is equals to, my load is what? 800,000, all right? Divided by what? My effort. So this is over 1. I can actually say cross multiply. Right, so 800E is equals to what? 80,000. What do I do to find E? I will divide by the coefficient of what? E, which is 800. So this cancel this cancel this, right? So I'm left with effort to be 1,000 Newton. Is that clear? All right, my effort is 1,000 Newton. Okay. Now, what else do I have? The next thing I have to do is to solve for my what? For my work done by the effort. Now, for you to solve for the work done by the effort, you are going to use, that is the last part of the question, you are going to use efficiency is equals to work output over work input, then multiply by 100%. You know what is work output? Work is force multiplied by distance. And don't forget that load is a force and effort is a force. So the output is the work done by the machine, while the input is work done on the machine. Okay, so efficiency is 80 over 1 is equals to, the work output becomes load times distance moved by what? Load, all over the work input, which is what you are looking for, multiplied by 100%, right? So going by that, this becomes 80 over 1 is equals to, our load is 800,000, okay, multiplied by distance moved by load, which is 20, and I got it to be what? 0.2 meters, divided by work input multiplied by 100 over 1, okay? So for me to get the work input, I'm going to multiply all through and divide by the coefficient of work input, which is what? 800,000 multiplied by 0.2 times 100 is equals to 60 million, now divided by 80. So my answer becomes 200,000 joules, which is the same thing as saying that this is 200 kilojoules. Do you understand what I just explained? All right, I said that for us to be able to do this, what we are going to do is to use our efficiency for solve for work output over work input. What you're looking for is the work input because it's the work done by a person in raising the load. That becomes work input. Okay, so putting our efficiency formula, then our work is 800,000 multiplied by distance moved by load over work input, which is what you're looking for. Then multiply by 100 over 1. By the time you multiply all this one and divide by 8, you are going to get your answer to be 200 kilojoules. Hope that is clear. All right, put it down. All right, put it down. Let's proceed. Are we done writing? Let's move to the next one. Are we done? Fubara, Okechukwu, are we done? Please, are we done? Let's proceed. All right, so let's proceed. All right. Veronica, I believe you can see it clearly now. So copy fast. Let's solve. Adomneki, thank you so much for coming. I really appreciate. Thank you so much. God bless you. All right, are we done writing? Let's proceed. Veronica Osakwe Fubara, are we done writing? Are we done writing? Okay, let me explain. All right, this machine is called wheel and axle. It is used to lift water from deep well or to raise heavy loads, such as anchors of ship. This is just what we normally use to raise water from deep well. We use it to raise water from deep well, so it's also an example of what a machine because it helps our work to be easier. Now we have wheel. This is what the axle. Now this is classified as the load, which is where your energy is required, and this is where you classify as the effort where your energy is required, and this is what the load, which is the maybe the container used to carry water from the deep well. All right. Now what is important in this part of machine is our velocity ratio, which will help us to solve problems. Of wheel and axle is the radius of the wheel over the radius of axle. Now, in this type of machine, mechanical advantage equals the velocity ratio. And in a nutshell, we can say that the velocity ratio of this machine is big R over small r. So radius of this wheel is said to be what? Big R, while the radius of axle is said to be what? Small r. So we're going to be looking at an example involving wheel and axle machine. All right. All right. Please copy fast. Let's solve. Fubara. Fubara, can you see it now? All right, so let's solve. In a wheel and axle mechanism, the diameter of the wheel and axle are 40 centimeter and 8 centimeter respectively. Given that the machine is 80% efficient, what effort is required to lift a load of 100 Newton? Now, in this question, the first thing to do is to set our parameters. They give us the diameter of the wheel and the axle. So that means, know that diameter is equals to, diameter is radius over what? 2, right? Diameter is radius over 2. Now, it's just like, since we have the same diameter, we can equally use it to solve whatever you are looking for. The first diameter is what? Is 40. We can say 40 over 2. While the second one is what? 8. That is 8 over 2, right? Now, this will give me 20 centimeter, and this will give me 4 centimeter. Is that clear? All right. So the next thing we are going to look for is to actually solve for our velocity ratios. But let's set all our parameters. The efficiency is equal to 80%, right? And you're looking for the effort, and we have a load of 100 Newton. Now, the first thing that will come to our mind is to find our velocity ratio. Velocity ratio of a wheel and axle machine is what? Radius of wheel over radius of what? Axle. Now the first one is radius of wheel, which is given as 20, and the second is radius of axle, which is given as what? As which is given as what? 4. Is that clear? All right. All right, so let's go. My velocity ratio is equal to, I'll have 20 over 4. So my VR is equals to what? 5. Now for me to get my effort, I'm going to use efficiency is equals to MA over what? VR multiplied by 100%. Okay? Now let's substitute into what I have by saying that efficiency is 80 percentage over velocity ratio, which is what? 5. Is that clear? Alright, so multiply by 100 over 1. Now bring it down to half. 80 over 1 is equals to 100 times MA is going to give me 100 MA over 5. If you say cross multiply, we have that 100 MA is equals to what? 400, right? Okay, so we divide both sides by what? 100, 100. Therefore, my MA is equals to what? 4, right? Now, since I'm looking for the effort, MA is equals to load over what? Effort. That means 4, which is what I got, is equals to 100 over what? E. Therefore, my effort is equals to 100 over what? 4. My effort is equals to 25 Newton. This is actually a jam question, so you can see you don't really need calculator to solve this particular question. Now, let me do a recap. In a wheel and axle mechanism, the diameter of the wheel and axle are 40 centimeter and 8 centimeter respectively. Given that the machine is 80% efficient, what effort is required to lift a load of 100 Newton? Now, for you to be able to solve this, what you are going to do is to look at the radius of the wheel, where we have diameter is radius divided by 2. Okay, now for you to get your radius, you're going to say diameter over 2. Okay, so whatever thing I have here is diameter divided by 2. I have my radius of the wheel to be 20. The same method, I have my radius of the axle to be 4. All right, then the efficiency is given as 80%. They asked to find the effort, and we are given the load. Now, our velocity ratio equals to R over small r. That means 20 over 4 to give me what? 5. Remember, it's a dimensionless quantity, so it doesn't have a unit. Now, relating this to get our mechanical advantage, EF is equals to MA over VR multiplied by 100%. Now, we have the efficiency is equals to 80 over 1, and then is equals to what? I can't look for my effort without looking for my MA, which is mechanical advantage. That is MA over what? 5 multiplied by 100 over 1. Now we'll do it again by saying our 80 over 1 is equals to MA multiplied by 100. That is 100 MA over what? 5. Alright? So we do cross multiply. This is 100 MA is equals to 400. Alright? So we divide both sides by what? 100. So my MA is equals to 4. So what do we do next? My MA is equals to load over what? Effort. Alright, so my MA is 4 is equals to, my load is already given as 100, and my effort is what I am looking for. By the time I do cross multiply, you now realize that my effort will be 25 Newton. Is that clear? Alright. Alright, put it down. Let's proceed. All right, is it clear now? So we can move to another part of it, then we can conclude with today's class. Fubara, can you see it now? All right, are we done writing? All right, Osakwe, Fubara, Veronica, are we done? Are we done? Let's move to the next one. All right. Please put it down. All right, please put it down. All right, are we done writing? Let's proceed. Okay, let me explain. Gear wheels. These are commonly used in cars, bicycles, and cranes. In this machine, the principle of wheel and axle is applied to the two wheels of different radii connected by a belt and rotated on a different shaft. Now, what am I trying to say? This type of machine uses the principle of wheel and axle. All right? Okay, so we have this wheel, we have this one. We have this a smaller wheel, why this one is what? This is a larger wheel, why this is a smaller wheel. So they are all applied at different what? Different radii. They have their different radii, right? Connected with what? A rotating shaft. Because it uses the principle of wheel and axle. The velocity ratio is the number of teeth on driven wheel, but the number of teeth on what? Driving wheel. That is just it. And the essence of us discussing this type of machine is just for us to pick the velocity ratio and use it to solve problems. Is that clear? So let's see an example of how we can apply the knowledge of this to solve problems. So let's go. All right. We can't find question under this particular type of machine, but we can solve one other example on machines. We can end the class. All right, so you can attempt this question. Let's see if we have an idea of how we can solve it. Okay, so be fast. You have few minutes to do that, so we can conclude today's class. All right, can we send in our answers? Afubara Osakwe, what do you have? Can you send in your answers? Let's solve together so we can end today's class. Are we sending our answers? Let's see what we have. Yes, I'm still waiting. All right, so let me solve so you can confirm what you have. Cost of time. The question says a screw jack 25% efficient and having a screw pitch of 0.4 centimeter is used to raise a load through a certain height. As the handle turned through a circle of radius 40 centimeters. Calculate I, the velocity ratio of the machine, I, the mechanical advantage of the machine, and I, the effort required to raise a load of 1000 Newton with this machine. And we are giving 142. Alright, so let's clean up and solve. Alright. I'm going to be reading out the question so we can be stating the parameters here. A screw jack is 25% efficient. So that means the efficiency is, and it has a screw of pitch 0.4 centimeter. So pitch is 0.4 centimeter and raise a load through a certain height. If in the process the handle turns through a radius of, so my radius is 40 centimeter, and we have the load to be 1000 Newton. Now what are we looking for? And they gave us pi to be 3.142. Now the first question we asked to find the velocity ratio. Okay, for us to be able to find the velocity ratio, you must look at this unit. The pitch has a unit of centimeter, while radius has a unit of centimeter. So you don't need to convert. The previous one we saw, one was in centimeter and the other was in. Since both of them have the same unit as centimeter, you're just going to work it out that way. So we have the first one, which is velocity ratio. The formula is 2 pi r over pitch. The formula for the velocity ratio of a screw jack. Okay, so VR is equals to 2 pi. We can remove the value of pi because pi is given as 3.142. 2 multiplied by 3.142 multiplied by radius, which is 40, then divided by what? The pitch, which is 0.5, 0.4. Okay, now let's work it out. With the help of your calculator, 2 times 3.142 then multiplied by 40 is equals to, we have it equals to 251.36 and divided by 0.4. Okay, now VR is equals to that divided by 0.4. So the answer becomes 628.4. Remember, it has no SI units. And the next thing we are going to solve for is efficiency. Is a mechanical advantage, sorry. That's the next question. The mechanical advantage, you're going to use efficiency formula. Efficiency is equals to MA over VR multiplied by 100%. All right. My efficiency is given as 25, so 25 over 1 is equals to, I am looking for MA divided by VR, which is 628.4, then multiply by 100 over 1. Is that clear? So I can do cross multiply by saying 100 MA is equals to 25 multiplied by 628.4. Okay, so I have 15710. I divide both sides by what? 100. 100 cancels what? MA. And the answer becomes 157.10. Remember, it has no SI units. And the next question we are going to look at is the effort. Remember that MA, which is mechanical advantage, is equals to load over what? Over the effort. Now we have a load of 1000. Now let's substitute into what we have. That is 157.10 is equals to, the load is 1000 divided by effort, which is what? E, right? Now say this is over 1, cross multiply. So we have that 157.10 is equals to what? 1000. Then I'm going to divide both sides by 157.10. Okay, so let's work it out. 1000 divided by 157.10, and my answer becomes 6.37 approximately what? Newton. Is that clear? Now let me do a recap. In this question, I said earlier, after setting your parameters, you check if there is need for conversion. Now my radius and my pitch is the same unit, so we don't need to convert. So the first question we are asked to do is to find the velocity ratio, and the formula is 2 pi r over pitch. Now my 2 pi is already given as 3.142 multiplied by radius, which is 40, and my pitch, which is 0.4. Now by the time you work it out, you're going to get your velocity ratio to be 628.4. It has no SI unit because it's a dimensionless quantity. So the next is to find the mechanical advantage. We are going to use this formula to find the mechanical advantage because we already have efficiency. So efficiency is equal to MA over VR multiplied by 100%. Now substituting into what we have, we say cross multiply, and we got our MA to be 157.10. Okay? So mechanical advantage is equal to load over what? Effort. Now what is this? This is 157.10 is equals to, which is what I am looking for. By the time you say cross multiply, is equals to 157.10 E equals to 1000. Then we divide both sides by the coefficient of this, and my effort becomes 6.37 Newton. Is that clear? Right. All right, put it down. Let's conclude for today. All right, we have come to the end of today's class. So I'm going to put up your assignment to the community so you can go to my channel, search on the community and see the assignment for today's class so you can solve it. Is that clear? Like I always tell you, physics is a subject that needs more concentration. The more you solve, the more you know it better. I will see you next time in the next one. Bye for now.